In this video, we're going to look at an example of the rational root theorem that helps us find all the zeros of a polynomial. So, we're being asked to find the zeros of f of x equals 2x cubed minus 9x squared plus 4x plus 15. So we'll use the rational root theorem here to help us find all the possible rational zeros. The factors of 15 are 1, 3, 5, and 15. We can use plus or minus any of those. The factors of 2 are 1 and 2. So we make all the possible fractions using these as our numerators and these as our denominators. So these first 4 represent the factors of 15 over 1. The second 4 represent the factors of 15 over 2. We've got 16 possible rational roots. That would be a lot to test. So we'll use a graph to help us figure out which ones we might want to test. So here's a graph, and again, we're just interested where it crosses the x-axis. I'm not interested in the actual shape of it here. Looks like it crosses the x-axis at -1, at 2.5, and 3. So the first thing we'll do is we'll just try one of these, because again, our whole goal of this is to try to knock it down to a quadratic. Once we get to a quadratic, we should be able to factor it, and if we can't factor it, we will use the quadratic formula. So I'll try -1 first. Here are the coefficients of the polynomial. Bring down the 2. Multiply by the -1 to get -2. Add down to get -11. Multiply to get 11. Add down to get 15. Multiply to get -15. Add down to get 0. So we started with a cubic. This is a 0. We now have a quadratic. We can solve quadratics again either by factoring or by quadratic formula. The quadratic we have is 2x squared minus 11x plus 15. We want to set that equal to 0. This actually does factor. If you don't see how to factor it right away, you can always use quadratic formula. It will get you the same answers if you apply it correctly. This factors as 2x minus 5 times x minus 3. So that gives you that your zeros are -5 halves and 3. So our 3 zeros are -1, the one we found originally, the 5 halves, and the 3.